Like all clouds, fog is moisture in visible form. It differs from clouds in that it lies on or close to the Earth's surface, reducing ceilings and visibilities to near zero. Fog may vary from a few feet to many hundreds of feet in depth. Fog has the same appearance from above as a low sheet of clouds, making it difficult to tell from this angle whether it is on the surface or if there is a ceiling with some visibility underneath. With modern navigational aids, fog is of no concern during en route flight. However, fog-blanketed airports render takeoffs difficult and landings exceedingly hazardous. Fog usually forms more rapidly than other weather phenomena. It is difficult to forecast and is often an unexpected hazard. It is vitally important to have an alternate airport in mind when operating under fog conditions. All air contains moisture, usually as invisible vapor. If the air is cooled sufficiently, some of this moisture will condense out and become visible. The temperature at which the moisture begins to condense is called the dew point. The dew point is a variable factor and will increase as the air absorbs more moisture by evaporation. The air temperature also varies and will decrease as the air is cooled by contact with a cold surface. When the descending temperature due to contact cooling and the ascending dew point caused by the addition of moisture through evaporation become equal, fog will form. In air free of fog, there is a difference between the temperature of the air and the dew point. The amount of spread between these two is an important factor in prediction. With a large spread, the temperature of the air must decrease and the dew point must increase a great deal before they become equal. Consequently, the formation of fog is unlikely. But with a smaller spread, less cooling of temperature and increase of dew point will be required. And the possibilities of fog formation will be greater. The most important process in bringing the temperature and dew point together and forming fog is the lowering of temperature by contact cooling. In comparison, the increase of dew point through the addition of moisture is usually so small as to be negligible. Therefore, only the lowering of the temperature by contact cooling will be considered. Fog fog may be classified into two general types: ground fog and advection fog. During daylight hours, the land gains heat from the sun. At night, the heat radiates from the Earth and is lost to space without affecting the temperature of the air through which it passes. The land therefore cools, but the air above the surface retains its daytime temperature. If the minimum temperature of the land surface during the night is equal to or less than the dew point, the air next to the surface will be cooled by contact with the cold ground until the air temperature equals the dew point. This results in the formation of fog. The conditions conducive to the formation of ground fog are a clear, cool night with high moisture content and light winds. A clear night allows the land to lose the heat gained from the sun during the daylight hours. Sufficient contact cooling is then possible for the formation of ground fog. But if the sky is cloudy, the clouds prevent most of this heat from escaping and act as a blanket to keep the ground warm. The air temperature will not be lowered sufficiently to equal the dew point. Therefore, on a cloudy night, the formation of ground fog is unlikely. With a high moisture content, there will be less difference between the temperature and the dew point than where the air is dry. Where there is less difference between the temperature and dew point, less cooling will be required to bring the temperature and dew point together, and the possibilities of fog are greater. A high moisture content can be assumed by the pilot when the ground is wet, as after a rain, or near rivers, lakes, or small streams. Ground fog may be intensified by light winds. During calm nights, if ground fog forms, it is very shallow, being only 2 to 4 feet deep. This is due to the fact that air itself is a very poor conductor of heat or cold. Consequently, only the air next to the surface is cooled, and this cooling process is distributed through only a few feet vertically. Under the same conditions, but with a wind velocity of from 2 to 5 knots, The cold air is lifted mechanically to higher levels by the action of the wind. This distributes the cooling through a deeper layer and may result in a deep fog formation. Still under the same conditions, but with a wind velocity of from 5 to 8 knots or higher, the increased mixing will so thoroughly spread the cooling process that the air temperature will not be lowered sufficiently to equal the dew point, and ground fog will not form. Thus, the nature of the wind circulation may intensify ground fog or may prevent it from forming. Ground fogs are more frequent and more dense in lowlands. This is because the air next to the surface will cool during the night and drain down into the valleys, resulting in a thick accumulation of fog while the higher ground remains clear. Around industrial areas where smoke is prevalent, fog is also more dense and more frequent, since the smoke particles act as additional nuclei for the formation of more fog droplets. Ground fogs generally form during the early morning hours and are uncommon before midnight. Their greatest density is normally reached about daybreak. Ground fogs usually clear 2 to 4 hours after sunrise. A thick fog bank clearing more slowly than a thin fog. Since ground fog is a local condition generally found in a restricted area over land, danger can best be avoided by having an alternate airport in mind whenever fog formation is likely. If the landing field is found to be fogged in, fly immediately to the alternate airport. Do not circle hoping the fog will clear, as this only uses up precious fuel. Unlike ground fog, advection fog will usually cover a widespread area and may form not only over land, but also over the sea. Advection fog may occur whenever contrasting surface temperatures exist in a given region. Warm air moving from the warm surface over the cold surface will be cooled by contact. If the cooling is sufficient to lower the temperature of the air to the dew point, fog will form. Fog formed by this process is frequently carried from one point to another by the wind. Contrasting surface temperatures are common along coastal regions. When the land is colder than the water and onshore winds prevail, fog may form over the land. Whenever continental coastlines are paralleled by higher ground or ranges of mountains, The fogs formed along these coasts when onshore winds prevail will be confined to the immediate coastal plains area. The higher ground acts as a barrier, which prevents the fog from spreading farther inland. However, where no such mountain barriers exist, the fog may extend inland for many miles. This frequently occurs in the eastern half of the United States during the winter months, when warm, moist air from the Gulf of Mexico flows northward and is cooled by contact with the colder land surface. This action often causes a widespread area of advection fog, which may extend as far north as the Great Lakes. When the water is colder than the land and offshore winds prevail, fog may form over the water and extend for many miles out to sea. Contrasting surface temperatures are also found in the open sea when warm and cold water currents are adjacent. Air flowing from the warm water surface out over the colder water may result in the formation of fog over the colder surface. Fogs formed in this manner may cover a large area of the open sea and remain dense both day and night for days at a time. This type of fog is common around the coast of Newfoundland, where warm air from the south is cooled by the cold water of the Labrador current. These fogs occur during all seasons of the year, but are particularly frequent and more dense between March and September, when warm winds from the south are more common in that region. The same condition exists in the Aleutian Island region of the North Pacific, when warmer air from the south is cooled by contact with the cold ocean currents of that area. Flight operations are seriously impaired and are most difficult in regions of widespread advection fog. Over the land, these fogs tend to thin during daylight hours due to the heating of the land by the sun. If the fog bank is shallow, it may even clear completely, but will form again after sunset as the land cools. However, when there is a deck of clouds above the fog, it will remain dense during the day. These clouds prevent most of the sun's heat from reaching the land surface. The fog, therefore, is not affected to any extent by the slight increase in the temperature of the land. Over the open sea, there is practically no variation in the thickness of advection fog between night and day, as the surface temperature of the water remains nearly constant. Advection fogs tend to dissipate on the leeward side of islands during daylight hours if there is no cloud deck above. As the air moves across the island, it is warmed by contact with the land, reaching its maximum temperature on the leeward side. This causes the fog to dissipate sooner here than in other areas around the island. A squadron of 18 bombers took off from a coastal base one afternoon to destroy certain enemy installations. At the time of the takeoff, the weather was clear with unlimited visibility and a moderate onshore breeze. A bank of fog lay over the water off the coast. After the mission had been completed, with all bombs dropped on the target, and without the loss of a single plane, the squadron returned to its home base. A dense fog covered the coastal plains region, blanketing the landing field. One pilot out of the 18 estimated the situation correctly and proceeded inland, knowing that this type of fog is usually confined to the immediate coastal plains region, and that a few miles inland, open fields might be available for a safe landing. 15 of the planes circled over the fog until their gas supply was gone. The crews then bailed out. 2 of the pilots attempted to land in the fog and crashed. 17 planes were lost, and 2 experienced crews were killed because of a local weather condition. This incident could have been avoided if, at the time of takeoff, all the pilots had recognized 2 significant factors. A bank of fog lay offshore, and a moderate onshore breeze prevailed. These conditions indicated the probability of fog blanketing this area after sunset, because the land becomes cool at night, allowing the onshore breeze to carry the bank of fog in over the coastal plains. Such conditions are common along coastal regions during the fog season. It is always a good practice to make a careful study of weather conditions before departing on any flight, giving special attention to all weather factors contributing to fog formation. Don't get caught. When there is any possibility of fog forming, always have an alternate airport in mind. Plan your flight so that sufficient fuel is aboard to safely execute the alternate procedure.